Okay, so we're going to take the derivative of y is equal to x times 6 to the negative 2x. So this is going to involve this equation here because we have an exponential where our base is 6, so the a is 6, and the u will be 2x. So let's actually go ahead and write that. U is 2x. It means du dx. Oh, sorry, negative. U is negative 2x, so then du dx will be negative 2. Now, this also is going to involve product rule because you have x times a function. So we'll take the derivative of x first. So we'll have that y prime will be equal to the derivative of x, which is simply just 1. And we're going to hold the 6 to the negative 2x as constants. Then plus, now the x stays as a constant, plus x. Then we take the derivative of 6 to the negative 2x. So the derivative of 6 to the negative 2x using this equation will be the natural log of 6 times 6 to the u, or 6 to the negative 2x, times du dx, which is negative 2. And then we can maybe like simplify this a little bit by factoring out the 6 to the negative 2x from each of those. So we get the y prime will be 6 to the negative 2x times 1 minus 2 times the natural log of 6. There's not really anything else you can do to really clean that up further. Okay, let's look at the next one. So now we have g of alpha equals 5 to the negative 1/2 alpha times the sine of 2 alpha. Now don't let the alpha throw you off, because that tends to throw a lot of people off, like right away, like, what am I supposed to do with that? Alpha is just your variable. Alpha could just be like your x or something. So think of it just like an x. So again, you're going to have product rule along. We're going to use with we're going to use equation 2 here. So let's first take the derivative of 5 to the negative alpha over 2. So we're going to make the u equal to negative alpha, to the negative 1/2 alpha. And then that just means that du dx would be negative 1/2. Again, don't let the alpha throw you off. If it was negative 1/2 x, the derivative of negative 1/2 x is just negative 1/2. Okay, so then the first part we'll have, well, g prime of alpha will be equal to, so our 5 will be like our a, so we'll have the natural log of 5 times a to the u, or 5 to the negative 1/2 alpha, times du dx, which is our negative 1/2. And let's not forget the sine of 2 alpha. That just holds as a constant due to the product or sum rule, product rule. Okay, then to this, we're going to add this. We're going to hold now the 5 to the negative 1/2 alpha times the derivative of sine of 2 alpha. To take the derivative of sine of 2 alpha, you're going to use chain rule, where you're going to take the derivative of 2 alpha, so the derivative of the inside, which is just going to be 2. So times 2 times the derivative of the sine function, which is the cosine function, so times the cosine of 2 alpha. I don't know if I can fit it in. Times the cosine of 2 alpha. I hate squeezing stuff in like that, but there's really not much you can do to clean this up. Maybe you can just factor out the 5 to the negative 1/2 alpha from each side. So maybe you can rewrite your final answer is that g prime of alpha will be 5 to the negative 1/2 alpha times the negative sine of 2 alpha times the natural log of 5. Over 2 plus 2 times the cosine of 2 alpha. That's about it. So that's your answer. And this last one, we have a logarithmic function. So we're going to use this equation to take the derivative. Before we do that, though, let's use the power rule, power property for logarithms. So let's bring that 3 as a coefficient, so we can rewrite g of t to be equal to 3 times the log of t squared plus 7 to the base 2. Then we just take the derivative of this, and whatever we get, we multiply by 3. So we'll have g prime of t will be 3 times. So here we have the logarithmic function where the a is 2 and the u is the t squared plus 7. So u is t squared plus 7, and that means du dt will be 2t. And so to take the derivative of this expression, we're going to have 1 over the natural log of 2 times the u in the denominator, so times t squared plus 7. Times du dx, and our du dx would be just 2t on top. That doesn't come out too messy. And so then we'll get 6t on top over the natural log of 2 times t squared plus 7 as our final answer.